An air traffic controller spots two planes at the same altitude converging on a point. So they're coming together at one point as they fly at right angles to each other. So that means their paths will make a right angle. One plane is 150 miles from that point, moving at 450 miles per hour. The other plane is 200 miles from that point, moving at 600 miles per hour. A basic picture of the situation has been provided. At what rate is the distance between the planes decreasing? The distance between the planes is that straight line distance. That means if we just drew a straight line from one of them to the other. And so I see that that is this side of the triangle. And so I can mark that. I'm going to mark that with the Z. I'm also going to write what rate here. It says what rate is the distance. And so I know that we want the rate of that distance of Z. So that's going to be dz dt. It means we're looking for dz dt. I'm going to label the other sides here x and y, just so I have three different variables that I can use. In order to try to figure this out, I realize that since I'm talking about this x distance, this y distance, and the z distance, and this right here is a right angle, I can use the Pythagorean theorem here to help me solve this. I know that x squared plus y squared will have to equal z squared. Okay, that's true, but we don't want z squared, we want dz dt, and the way to do that is that we now need to think about our related rates, and we're going to have to find the derivative of all of these terms with respect to t. So x squared will become 2x dx dt plus 2y dy dt equals 2z dz dt. Now, one issue is that we don't know what any of these things are, and so we need to look back in our question to figure out, well, what are the things that we can use, and what are the things the question's giving us, and we can put that into our toolbox. I'm going to draw that over here. Again, I like to call this the known toolbox. Known toolbox. What are the things that we know? Well, let's look. One plane is 150 miles from the point, moving at 450 miles per hour. So let's say it's this plane. Let's say it's this plane right here. If this plane is 150 miles from that point, that means x equals 150. And also, it's moving at 450 miles per hour, so that means dx dt will equal, and since it's moving closer to the point, that distance is getting smaller. It's moving at negative 450 miles per hour. Now we know y for the second plane, it says, is 200 miles. And dy dt, again, that distance is getting smaller, so this will be negative 600. These are the things that we know, but we need to, so we'll just plug in all those things. So now we get 2 times 150, and dx dt is negative 450, plus 2 times 200 times negative 600 equals 2 times, z, which we don't know, and dz dt, which we're trying to solve for. In order to find z, we're going to go back to our original equation up here, and I'm going to highlight this in yellow, because this equation gives us something that we can use to solve for z, because we know what x and y are, and we just need to find what z is. Maybe I should have highlighted it in green. I'll do that now because I'm going to write it in green. Over here. Right here. X is 150, so 150 squared plus 200 squared equals z squared. 150 squared is 225,000 plus 400,000 equals z squared. 625,000 equals z squared. And I know this already, but z is going to equal 250 once we find the square root of both sides. And in this case, we know z is positive, right, because that's a distance. The distance between those two can't be negative here. And so z here is 250. We can plug that in, and then we can solve this out. 2 times 150 is 300. 300 times negative 450. Let me grab my calculator. 2 times 150 times negative 450. This is negative 135,000 plus 2 times 200 times negative 600 is negative 240,000 equals 500 dz dt, because that's what we're trying to solve for. On the left side, I add those together, I get negative 375,000 equals 500 dz dt. And then we're going to divide both sides by 500 so we can get dz dt by itself. And then we find negative 750. Negative 750 is dz dt, and our units, because this is talking about the rate at which that distance is changing over time, it's distance over time, miles per hour. So dz dt is negative 750 miles per hour. And now in this context, the question is already asking at what rate is it decreasing? And so we can just say it's decreasing at 750 miles per hour. Because the decreasing already tells us that it'll be negative.